The history of the vehicle was the exhaust system was modified and the sensor was replaced multiple times. And I believe in the video, when I watched it last night, the student had 4 different oxygen sensors replaced for this fault code, and it would not go away. 4 different sensors. So it was at 2 different garages, and had a Hyundai sensor put in it, had aftermarket sensors put in it. They tried everything to fix the fault code. It would not go away. So I get it, and of course, what do I see? There's my fault code in memory. I have my slow response trouble code. This is before I started the car. I'm looking at my bank 2 sensor 1, bank 1 sensor 1, O2 sensors. I don't know if I just started the car or this is before I started it. I want you guys to take a look at a number here and remember this because we're going here later. This 429 and 424, it's pretty typical to see that with a cold sensor, and this is known as bias voltage. Remember that? We're going to that later. Might not be today, it might actually be tomorrow. We talk about O2 bias. But basically, the sensor's cold, and the next page, I am holding it at probably $2,000, 2,500. Why? Because I need to heat the sensor, and I'm using scan data to look at both first. And remember what we just talked about. We can't see frequency on the scan tool, but can I do comparisons with my 2 upstream O2s? And the answer is yes, and we can clearly see a difference. I can see that my bank 1, sensor 1 right here, that's the one that's setting the slow response trouble code, is definitely sluggish compared to the bank 2 upstream O2. Everybody comfortable with the amplitude readings? Are you guys okay that these aren't quite dropping down to my 200 millivolt line? You might not be, but I am, because this is scan data. And is it possible that signal is dropping below 200 each time? It's just the sample rate of this scan tool and the communication to the engine computer. I'm missing it, and the scan tool graph is playing connect the dots with the signal. That's what's most likely happening there. Do not overanalyze a graphed scan tool capture. So the picture to the left is very sluggish compared to the right. And what I start talking about in the video, and I really was filming live, I had no idea what the problem was. Actually, let me ask you guys, what do you think we should do next? The sensor's been replaced 4 different times. Very good. That's exactly what I talked about in the movie, is we should probably focus on the heater circuit. Wouldn't you guys agree? If it's a heated oxygen sensor, we need to check the heater circuit, make sure it's functioning properly. Remember that heated O2s can be put anywhere in the exhaust, and that if they're further downstream from the exhaust manifold, the heater circuit becomes even more important because the exhaust gas isn't hot enough to get the sensor working properly. So one of the things that I did in the video to check the heater circuit first, and I think I have this capture, let me see. I think I did all right, that's 2,500 RPM. The next one I'm showing it to you at idle, and you see how sluggish it is at idle. It's real bad at idle. And the next thing I did is I looked at my downstream O2s. So now at this point, here's my upstream setting the slow response code. That's my other upstream on the other bank. I'm looking at the CAT on the other bank. This is the downstream, and here's the downstream on the one with the slow response fault code. One of the things we'll be talking about in this chapter is what the downstream O2s are used for, and it's CAT monitoring. And what I said in this point in the videos, I didn't like this. This is more what you want to see over here, and this one, my question is, why is the downstream sensor moving like that? What that suggests is the CAT is dead on that side. At this point in the video, I'm thinking, okay, that can make sense. If we have a problem upstream on that bank, that maybe that CAT melted somewhat and stopped it performing like it should be from the issue that was in the upstream sensor. Back to 2,500. I don't like this. You guys understand that a downstream behind the cat sensor should be pretty steady when you're looking at it. We don't want to see those big swings in oxygen levels because the cat stores oxygen and uses it in that process. So downstream O2 should be steady with a good cat. What's that look like? Bad cat. Different subject, maybe, right? So looking at this a little bit closer, I don't think I did it in the video. I don't like that this one occurs before this one. In other words, what I'm looking at here is in this waveform, this one is going rich before, in time, before this one is. And it's dropping lean before in time than this one is. That's a little clue on what our problem is. 3,000 RPM, now I'm checking the heater circuit, Brandon. So this is the point where I'm thinking, could my heater be malfunctioning on this bank 1 sensor 1? And by holding it at 3,000 RPM, there's more exhaust gas moving past the sensor, and it's a quick way you can check the heater circuit. If it improves and starts looking like the bank 2 sensor 1, if it starts looking like this one, then maybe we lean toward the heater circuit, and I saw no change. It's still pretty sluggish compared to the bank 2. So now I'm concerned about wiring, and I have seen Scan Tools report the wrong sensor. So what I'm thinking about now is, well, maybe they have been changing the bank 1 sensor and it really was the bank 2 that had the problem. And this was actually something I didn't talk about on this waveform. And this was an issue with Nissan and Snap-on, that the sensors would be misidentified. This blue trace, this was a bank 1 sensor 1, and the red trace was a bank 2 sensor 1, but they were actually backwards on the scan tool. So if you were looking at the OEM data, the bank 2 was reporting, and it would actually be the bank 1 sensor 1 where it would get that info, and the bank 2 sensor 1 is actually getting its bank 1 sensor 1 info, and the trouble codes would be opposite too. But then you'd go under OBD2 generic, and they would be correct. So the issue was under the OEM. I got burned on that before. I had this Nissan come in with bank 1 sensor 1 fault codes, and we changed the bank 1 sensor 1 sensor because I used the OEM data to troubleshoot it, and the car kept coming back with bank 1 sensor 1 fault codes. It just so happened that maybe the third time it came in, I decided to check the global data, and it was a bank 2 trouble code. Even the trouble codes were backwards. So what I'm telling you is, I've seen this before, that a scan tool can misidentify which sensor's fault, and that was a glitch with the Snap-on scan tool. I don't know if other manufacturers had that issue, but it wasn't unprecedented, and that's what I'm thinking about with this Hyundai at this point. Is this bank 1 sensor 1 really the bank 1 sensor 1? So how would you guys handle that? What could we do?
Check global, like you did the Nissan.
We could do that. We could check the global data and compare it to, and this one's not a Nissan, this was a Hyundai, but absolutely we can do that. Look at your global data, compare it to the OEM, make sure they're giving you the same information. That's very good. I wasn't even thinking about doing that, but that's absolutely one method you could use. What's another one? What?
Could you isolate it by just pulling the plug?
That's exactly what we can do, is isolate it by unplugging the O2. Now to do that, we need to make sure that we're unplugging the correct O2 sensor. So what we would need is, we'll need a cylinder layout where, we pull the diagram for the engine, and we see that it's transverse mounted. This is the front of the car, and we figure out where is the number 1 cylinder is what we need to know. Right? We get our firing order, we figure out where number 1 cylinder is, and let's say that it's the front bank is number 1, then that means that the upstream O2 on this side would be my bank 1 sensor 1. Right? That's what we need to do. And I believe I did in the video. exactly that. And the information I found said that the bank one was the front one. It ended up not being that, but that's what we're doing. I'm going to unplug sensors. Right, next page, I'm just showing you in the video that I'm looking at the O2 connector, and pretty tough to see here, but I see a blue wire here, I see a white wire here, and you can't see the two blacks, they're underneath. Well, that sounds familiar, doesn't it? Two blacks, a blue and a white. I know which ones my heater circuits are. Different subject there for checking the heater, but that's my O2 connector. I unplugged it, and this is what I saw on the scan tool. A working O2, and then all of a sudden a flat line of around 400, that's 424. 424 millivolts. Again, this is a bias. We'll talk about this, we need to. That's not coming from the sensor, it's coming from the computer. It's a normal unplugged reading. So what do I know about this car? The sensor I just unplugged on the front is bank 2. I'm using the car to tell me what sensor's what. You guys follow? And you understand my concern. The sensor's been replaced 4 different times. Still got my crappy O2 waveform, and I at least know where my bank 1 is, which is on the firewall side. And then I unplugged that one next. And I have the same thing, a 424 millivolt bias. So then I think at this point I questioned the owner and which ones were changed, and he actually told me that they changed all of them. So as far as them not changing the correct sensor, that's kind of not in my radar anymore, and I'm left with, again, what Brandon said, let's check the heater circuit. And so to check the heater circuit, I need a wiring diagram, right? To know which ones the heater wires are. This is the bank 1, sensor 1, O2. Now that I know for sure which one the bank 1, sensor 1, this is the one I'm going to focus on. Do I need a wiring diagram? No, I don't. All I need is so that's the harness side of the connector. All I need to do is look at the sensor side, and I know which one the heater circuit is without a wiring diagram. This is why we went over it in section 4. I'm trying to fix this car now. I don't feel like stopping to go get a diagram and figure out what my heater circuit is. Which ones are the heater wires? The 2 blacks. When you see these sensors and you see 2 colors that are the same, this is the heater circuit. So what are we looking for with the heater circuit? Powers and grounds. And at that point is where I found the issue. And it was just by looking at the connector, and I was looking at the wire, and I noticed that that wire did not go to the upstream sensor. It went to the downstream. Long story short, guys, they had the downstream sensor plugged into the upstream connector, and the upstream sensor plugged into the downstream connector.
So the upstream was getting heated and the downstream was not
Nope, the downstreams are heated. That wasn't a heater issue. They are both being heated. So let me see if I can explain it to you on this page. Well, this was after the fix. Let's see. I'm just going to draw the one bank. Here's your exhaust manifold. Here's your O2. And here's your cat. Here's your downstream sensor. Computer is looking at, here's your bank 1, sensor 1 wiring. And here's your bank 1, sensor 2 wiring. This would be my downstream down here. This will be my upstream up here. What I'm saying is the upstream was connected to the downstream sensor, and the downstream sensor was connected to the upstream. Which one is the computer looking at for fuel control? The computer is still looking at this one for fuel control, correct? Where is my fuel control now coming from, though?
after the
After the cat. So what's the cat do in its process? It catches and stores oxygen and does its thing. So isn't that going to delay the reaction of the O2? So think about it for a second. If the mixture's rich, computer takes fuel away, how much fuel does it take away? Until the O2 drops lean. Well, if it's behind the cat, doesn't the cat catch and store oxygen? And isn't that time that it's taking fuel away going to be longer before the O2 reacts? Because the cat has to be flooded now with oxygen before we actually get oxygen out of the cat. So what happens is it is going to delay that reaction time. And then the upstream, this is actually my downstream signal right here. This is my downstream. Where's the downstream at? It's actually reading up front. So does it make sense that the downstream is reacting first now to you guys on the scan tool? Because where is the signal coming from? This is actually the upstream. This is the upstream sensor. And this is the downstream sensor. You guys with me on this variable of a slow response? What's causing it? To be honest with you, a good cat's what's causing it. If this cat was dead, we wouldn't have this issue. You wouldn't even have a fault code for the sensor. What you'd have is a catalyst efficiency code, a P0420. But what are we talking about here? A slow response trouble code. Should we do some checks when we see them? This Hyundai was an example of one that you might not want to just throw an oxygen sensor at it. Now, granted, what made us go further with it is it already had all of the oxygen sensors replaced multiple times, and that's what it looked like when I was done.
So did he have a dealer do it or something?
I'm not sure. He did have an aftermarket exhaust put on it, and when he had the aftermarket exhaust put on it, the location of the sensors maybe were different. Not in the manifolds, but after the manifolds, the downstream sensors. And that's when the problem started. So I don't know if it was just simply carelessness or if they were actually relocated. But what I will tell you is this is not unprecedented to have the same connectors. And where the sensor location connector is, they can be right next to each other and have an upstream and downstream, and you can easily reverse them. This is not the only car I've seen this on. I have actually seen a throttle position sensor and an ignition coil have the exact same connector on a Chrysler or a Mitsubishi. And it was the crank sensor. The crank sensor was connected to the ignition coil, and the ignition coil was connected to the crank sensor. It's the same connector. Can you imagine how messed up a troubleshooting procedure you'd go through with that? You change the coil, that still don't have spark. You change the crank sensor, you keep getting crank sensor codes because you keep cooking the crank sensor with the ignition coil circuit.
Change all of them.
Yeah, so anyway, you got to look for that. Let's talk about this for a second. Based on Brandon's comment about checking the heater circuit, do we always need to get underneath and check the power and ground? The answer is no. And what we're going to do as we continue in this chapter, we're going to use this bias voltage. Green, you guys said you can see easier, right? We're going to use this bias voltage. This would be engine off, key on, engine off. And then right here is where I started the car. And you see how quickly this drops down in these. This is a matter of, there's 430, 440. Within 10 frames, I'm already dropped down past, pretty close to that 200 millivolt range. Why is that dropping that fast? Because the heater circuit's working. Remember that. This is where we'll use our bias as we continue. This is allowing me to not have to get underneath the car, check those powers and grounds on that heater. I know they're working. I'll show you some later that will reinforce that a little bit more. Keep going. Let me show you. This one is a misfire low power. It was a 2002 Rodeo, and I'll just give you the answer to this one right away. It had reversed upstream O2 connectors. Bank 1 was reporting into Bank 2, and Bank 2 was reporting into Bank 1. Now, how do you think the thing's going to run? Now, so this one, let's be clear. This is not a slow response fault code. This is a, holy crap, something's really wrong with this car issue. happen if I have a, say this is bank, we'll make that bank 2, this is bank 1. And let's put our computer over here, and this is my B1S1 wire. And here's my B2S1. These are the upstream O2s. Here's the sensor. This is bank 1. This is bank 2. The problem is, bank 2 is going into the bank 1 circuit, and bank 1 is going into the bank 2 circuit. You guys follow the issue? What happens when this side, what happens when we get a lean signal here? An actual lean. So coming out of the manifold, we have a lean condition. Which sensor sees the lean condition? Bank 2. So we see lean on bank 2. What does the computer do to a lean signal on bank 2? Where does it originate?
B2.
On bank 2. So the command from this lean is to add fuel where? To my fuel injectors here. So what happens now? At that point, the bank 2 sees what? We get this exhaust coming out of here, and it's seeing rich, right? And so where's that rich signal going though? Bank 1 is seeing rich. And what does the computer do in response to a rich on bank 1? It takes the fuel and adds fuel. Sorry, wait. Takes the fuel away on bank 1. And so what do we continue to have on this one? All right, so what do you think my fuel trims look like on both banks? Bank 1, bank 2 fuel trims. This is bank 1's issuing a rich command, bank 2's issuing a lean command, and it never changes, it never reacts, does it? It just continues to go. So bank 1, what you'll see is maybe positive 40%, no plus sign by the way, let's say 40%, and bank 2's minus 40%. You guys with me on the fuel trims and why it would look like that? How do you think this thing would run? You understand why it would have a misfire? One bank's starving for fuel, the other bank's flooding fuel. Runs good cold though. Why does it run good when it's cold? O2s aren't being used. Runs good at wide open throttle too. Why? O2s aren't being used. So let's take a look at just some of the standout real quick. Showing the engine and showing the fault codes. That makes sense. So I got a system 2 rich on bank 1, right? Can you guys see that text? Is it hard to see? This is a 172, P0133. This is a rich code, 2 rich. This says rich. And then I have a P0174, which is a lean code on bank 2. This is 1, this is 2. Then I got these injector codes, injector circuit. Why do I have injector circuit codes? Because the guy, when he brought it to me, told me he had a 3-cylinder misfire. And when it would miss, he'd unplug the injectors on the one bank and there was no RPM drop. Well, which bank do you think that was? Probably the one that was taking all the fuel away. 1, 3, and 5. Oh, it could be the other one too. Doesn't matter. The issue was he was barking up the wrong tree. It was an O2 problem. And there were some other fault codes too, but they were unplugging everything. Showing the fuel trim here. This is the short term. This says minus 53.1, and the long term. This is short term on 1. Here's long term on 1. Minus 37.5. This is long term. This is short term on bank 1. And then short term on bank 2 is 18.8, and long term on bank 2 is 22.7. That's pretty crazy, isn't it? So I don't know, pretty good case study. You guys have to watch it. A note on this. All of a sudden, at this moment, check this out. How do you think the vehicle's running right here? It sounded like a 3-cylinder misfire on a V6 engine. That's what it sounded like. It was horrible. And then all of a sudden, this next capture, it started purring like a kid. Running great. What happened? What changed?
The O2 stopped being used.
Yeah, I not really seeing O2 signals here, and more importantly, check out my fuel trim. There's short terms at 0, long terms at 0. Short term and long term fuel trim are now at 0. What happened? What mode am I in this capture? What does CL mean under fuel system 1 and CL mean under fuel system 2? Closed loop, good. And then on this page, what do we see? What's OLFLT? Open loop fault. That's an open loop fault. Trouble code, what's the computer do? An open loop. That just squeaked there. It ignores the O2, right? This is an open loop fault. It runs great without the O2 problem. What am I doing here? Is this the same car? Looks like it. Oh yeah, I'm just showing the O2s themselves. This will be a good tie-in for where we're going. I'll let you guys break first, but when we come back from break, we're going to start talking about fixed O2 signals. And how do we determine if the sensor is dead and lying or contaminated, or do we have an actual mixture problem? Does that make sense? So here would be the two. If the O2's fixed lean, is the O2 fixed lean because the sensor's bad and giving a false lean signal, or do we have an actual lean condition causing the flatline low voltage on the O2? The second question would be, if we have a fixed rich O2, and I'm really showing that here. This signal is fixed rich at this point, right? Can you see the flat line? And this one is what? Fixed lean. And the question is, are these sensor problems or do we have mixture problems? What can we do? This is what we'll do when we come back from break. We'll talk about the steps. What I did in this video to show this is I did a couple of snap throttle tests. When we do snap throttle, what are we doing? Dumping a bunch of fuel and dumping a bunch of air into that exhaust. When does the air come? When we snap it, high RPM, we let off the throttle, computer shuts the injectors off during the decel event, so we get a bunch of oxygen into the exhaust. And when we snap it, we get fuel. So we get both. Can you see that both of my O2s react to that? So here's the question. I'll leave you with this for the next segment. How are the sensors? Sensors are good. It's as simple as that. If you have a mixture problem. This is one method we'll use. I'll show you the other ones when you guys come back from break.